The circuit with which we are dealing now are clippers. First, let's start off with the definition. A clipper is a circuit which prevents the output of the circuit from exceeding a predetermined voltage level without distorting the remaining part of applied waveform by removing either or both the peaks from the input waveform. Let's see some of the applications of clippers. Clippers are used to transmit the selected portion of an arbitrary signal which lies above or below a given reference level. The same is depicted in the graph. They are also used as wave shapers to convert sinusoidal waves into a square wave in digital circuits. In the graph shown, we can see how a sinusoidal signal is converted to a square signal. Clipping circuits basically are of two types, namely series and parallel type. In series type, the diode is connected in series with the load. In parallel type, the diode is connected in parallel with the load. In series clipper, output impedance is less as the resistance in the forward path is very less, that is, only the forward resistance of the diode. In shunt clipper, the output impedance is high as the 10 kilo ohm resistor comes directly in the forward path. It provides a very high impedance to the load. Let's get on to the working of the circuit. A positive shunt clipper is illustrated in the figure. Here, the diode is connected in shunt with the output terminals. In unbiased clipping circuit shown, when the input is less than 0.7 volts, the diode is reverse biased and only a small voltage drop occurs across resistor R1 due to load current IL. This means that the circuit's output voltage is approximately equal to the negative input peak. When the input crosses 0.7 volts, diode D1 is forward biased and the output voltage equals the diode forward voltage drop plus Vf. Let's see what has to be done if the level of clipping is needed other than 0.7 volts. We need to bias the diode such that it should conduct only at the required level, thereby changing the clipping level. One such circuit is given here. In the biased clipping circuit shown, the diode is forward biased only when the effective voltage at terminal 2 is greater than 5 plus 0.7 volts and the output voltage is limited to 5.7 volts. The excess potential drop is across R1. When the potential at terminal 2 is less than 5.7 volts, the diode doesn't conduct, and since the potential drop across the forward resistor R1 is very less, the output is almost equal to the input. Now let's see the simulation of the circuit. Here we see that the input fed is around 10 volts peak. Channel A of the CRO is connected to the input and channel B is connected to the output. We can see that the input of 10 volts peak is limited to just 5.7 volts in the positive half and the negative half is same as the input.